So now let's try some applications of these problems. So our first direction says rewrite each linear equation in standard form. So looking back at the chart we made, standard form is the ax plus by equals c. Is the final form we want these to look like. So if I look at this one, it looks like I've got my ax in the front, but my by is over here on the right side of the equal sign, and my c, which is supposed to be on the right, is over here on the left side. So I'm going to need to move the two y's over to this side and the minus 11 over to this side. So I can do that by subtracting two y's from both sides and by adding 11 to both sides. Now back in Unit 1 we would have done all of that in two separate steps. If you want to still do it in two steps, that's just fine. If you want to start combining some of these steps together, that's okay too. So now the form that I'm going to have is a negative 5x minus 2y's, because those two y's went away, is equal to a positive 11, because those two went away. Then now I've got my x term, my y term, and my constant term in the right place, but standard form says that that first term, has to be positive. So if I multiply through by a negative 1, it becomes 5x plus 2y equals negative 11. So now it's in standard form. Looking at this next example, the y is already on the right side, on the correct side of the equation, but the 3x is in the wrong place. And our constant term is on the right side, where it's supposed to be. So all I need to do is move these 1/3 x's over to the other side, giving me a negative 1/3 x plus y equals a negative 3/4. So now each of my terms are in the right spot, but I've got fractions, and the standard form says these need to be whole numbers. So I'm going to go through the same process that I did back in Unit 1 to clear fractions, that my lowest common denominator here is a 12. So if I multiply each of the terms, the 1/3 x, the y, and the negative 3/4 by 12, that will clear out these fractions. The other thing that I want to get rid of, though, is this negative sign, because the first number is supposed to be a positive. So if I multiply through by a negative 12, it'll get rid of that negative here at the same time, when a negative times a negative makes a positive. So carrying that 12 through, a negative 12 times negative 1/3 gives me a positive 12/3, which reduces to 4. Multiplying my y by negative 12, I get negative 12y. And multiplying the negative 3/4 by 12, I get a positive 36/4, which reduces to 9. In this next problem, we're asked to write the equation of a line with the given slope and y-intercept, and then express our answer in the indicated form. So the first question wants us to put our final answer in slope-intercept form. That's the y equals mx plus b form. So when I look at this, they've given me what my m is equal to, and they've told me what my b is equal to. So writing this equation in slope-intercept form is going to be pretty quick. I just replace the m with a negative 7, and I replace the b with a positive 4, and we're done. For this one, they would like the equation in standard form, but since I'm given a slope and a y-intercept, I'm going to start by writing my equation in the slope-intercept form and then rearrange it using algebra until it's in standard form. So this one will be y equals 6x plus 2, since my m is a 6 and my b is a 2. Then I need to get my x term to the other side and make sure that my leading coefficients are positive. So I'll subtract 6x from both sides of the equation. That'll give me negative 6x plus y equals 2. Then I multiply through by a negative 1 in order to get that leading coefficient to be positive. So that gives me a final answer of 6x minus y equals negative 2.